titration is a process used to determine the concentration of an acid or base solution of unknown concentration, called the analyte, by using an acid or base solution with a known concentration, called the titrant. If the base is the analyte, then the acid is the titrant. Today, Hannah and Dakota will determine the concentration of a solution of sodium hydroxide by using a solution of hydrochloric acid with known concentration. The indicator we will use to determine the endpoint when pH is 7 and there are equal number of moles of hydrochloric acid and sodium hydroxide will turn from blue to green when the solution is neutral.
To prepare the burette, first we have to rinse it with distilled water. We open the stopcock to let it go through. Maybe. It's going very slowly. Just a little bit of air. Now, we've done that. We have a volumetric pipette. And we are going to fill it, rinse it with some of our hydrochloric acid. It's 0.25 mole. Rinse with hydrochloric acid. Bam! Carefully.
Bad pipetting technique.
No, it works.
Vocabulary. Oh, that's strong.
There's a reason we're not pipetting. We should like turn the sound off and then like put a song in the background. Of us. We can put that serious song. And we do this to make sure there's no awkward ions hanging around from previous experiments. Now that it's conditioned, rinsed, I'm going to actually fill it using more proper technique. Actually want. And then you repeat that until it's at the desired volume.
I just mixed a 0.04 molar solution of sodium hydroxide, but I haven't told Dakota or Hannah, so we'll see if they can figure it out.
Okay. Okay, so we got our burette full of 0.25 molar hydrochloric acid. I'm going to check the initial volume. It's 13.8, which is actually more like 25 milliliters minus 13.8, which I think is 11.2. Because Dakota has a calculator and she's smart. I'm going to adjust the height of the burette. Set the flask under it. Have a magnetic stir bar under there. We're going to start it spinning. Actually, first, we need to put the sodium hydroxide with unknown concentration there. You want to do that? Sure. Be fancy. Our stir bar's already in there. We have no idea how much this is going to take. Hopefully we have enough. Indicator. Put in bromothymol blue indicator. It's going to turn blue and it'll be green when we hit the equivalence point. It's really blue. Okay, let's get this moving. Stirring away. Okay, ready to start. Are you ready? Yes. And acid, go. What are you doing? You keep going a little bit faster.
Rather than be stepping through and just video piece of it, did one at a time.
Right when the acid's in the water, it's turning a little bit yellow and fading away. It's acidic right there. Just turn it up. Yes.
That works. Yeah.
As we get more acid in there, it's going to slow down. It takes less and less to hit the equivalence point.
Yeah, well, I figured it would take me maybe a minute to run through just the list of things, them over one at a time, setting over. I guess is what I had in my head doing that, and because it should be 2 to 5 minutes for the video, and then a minute of setting it up.
A little bit faster magnetic stir plate. A little bit of acid at a time.
Verbal, yeah, talking through it, yeah. And then just videotape something to it.
Almost there.
I'm just trying to think of how would we set the camera to where, like, bring it in closer and zoom it in, and then one at a time underneath the camera.
Bullshit. That is yellow. That means we passed the equivalence point. Maybe. Let it go for a minute. Yes. That means we have just passed the equivalence point. Check the final volume, which is 20.1, which is actually 25 minus 20.1, which is 4.9. Yes. Yes. Report our numbers.
I think that's good. And then do the stop and go through that. Okay, so I'll set to the beginning here, and I'll try to
So,
relatively short.
calculator.
Okay, so
Do the math. 6.3. Okie dokie. This is where we actually do math. So, we took our total volume of hydrochloric acid in milliliters, converted it to liters. Then we used a molarity conversion to find the number of moles of hydrochloric acid by multiplying liters times moles and divide by liters. Liters cancel. End up with 0.001575 moles of HCl from this equation. We know that is a 1-to-1 mole ratio between hydrochloric acid and sodium hydroxide. So 0.001575 moles of hydrochloric acid converts to 0.001575 moles of sodium hydroxide. And then we found the molarity of the sodium hydroxide by using the moles, dividing it by the volume, which we know is 50 milliliters or 0.050 liters, and found a total molarity of 0.0315 molar sodium hydroxide, which may or may not be correct. So, Kayla, that's what decoded. What's the actual answer?
So the actual answer is 0.04.
We're wrong.
Close enough.
How much were we off? Let's find out.
Initially for the
21 points.
We were off by 21.25%.